So here are a couple extra practice problems if you're having trouble getting started with worksheet 6.3. So it says a Roman candle flies horizontally out of a person's hand at a velocity of 10 meters per second. So we have a person, and the candle is going to fly out of his hands and kind of make this parabolic path, trajectory. So we know that from our past slides that we know that the horizontal velocity stays constant the whole time, and as the candle flies out of the guy's hand, it's flying with an initial angle of 0, so there's not going to be an initial vertical velocity, and as the time increases, so will the vertical velocity. So if we make our little XY column and list what we know, it's telling me that it's flying horizontally out of his hand at a velocity of 10 meters per second. So that's telling me my horizontal velocity. And then it's also the person is standing on a hill that's 10 meters high. So that's telling me my vertical displacement. Horizontally, I know the velocity is going to stay constant because there's nothing pushing or pulling on it horizontally, so nothing's affecting the horizontal velocity. So over here, I'm only going to have 3 variables because it's moving at a constant velocity. And then vertically, as it falls, it's going to fall at a rate of 9.81. And it's speeding up as it's going down, so you can make all your variables, delta x, your acceleration, your velocity, either all positive or all negative. I'm going to choose to do make my variables all positive. So my acceleration, my delta x can be positive 10, my acceleration is going to be positive 9.81 meters per second squared, and the initial vertical velocity, since the angle is 0, there's not going to be initial vertical velocity, it's going to be 0. So I know if I drop something and I throw something horizontally, they're going to hit the ground at the exact same time. So I don't have enough information to solve for the time over here because it wants me to solve for the range. That's what the problem is asking me to solve for, is how far from the person does the candle land on the ground. So I need to know what the time is. So I don't have enough information horizontally, but I do have enough information vertically to solve for the time. So I can use one of my acceleration formulas, and this one jumps out to me. And I can plug my numbers in. The displacement's 10, 1/2, 9.81 time squared plus 0 times t. So that's just 0. And solving for t, I get a time of 1.43 seconds. So the time here is 1.43, and it's also the same time over here, 1.43. And so now I have enough information horizontally to solve for the range. So I can use x equals vt. The horizontal velocity they gave me in the problem was 10. We just solved for the time, 1.43. So my final answer is 14.3. All right, in this problem, it says a football is thrown at an angle of 45 degrees above the horizontal from the top of a hill with an initial speed of 9 meters per second. So if I have a hill and a person is throwing it, this angle right here is going to be 45 with initial velocity of 9 meters per second. So I'm already going to know that I'm going to have to make a triangle. And have to solve probably for the horizontal velocity and the vertical velocity. It says a stopwatch measures the football's projectile time from the top of the hill, from here all the way down to the bottom, it takes 5.6 seconds. And it wants to know what is the height of the hill, how high does the football go, and how far is the football thrown, so the range. So let's list what we know horizontally and what we know vertically, and we can start solving these problems. So it's telling me that the initial velocity thrown on the angle was 9 meters per second. So if I can use my trig functions to solve for the horizontal velocity, I can fill in that. So I'm just going to use cosine of 45 is equal to Vx over 9, which comes out to be 6.36. And I can use sine of 45 is equal to Vy over 9. And that also comes out to be 6.36. So they're giving me some more information. They're telling me that the total time is 5.6 seconds. And I also know that at the maximum height right here, that velocity is going to be 0. So the velocity, I'm going to say at the peak, is equal to 0. And the first problem wants me to figure out how high is the cliff. So let's solve that problem. So here's the information that I know, and then I also know that the acceleration is going to be negative 9.81, and I need to make sure that my initial velocity vertically is positive and the acceleration's negative, because as it goes up, it's going to slow down and then it speed up as it makes its way back down. So I need to have opposite signs for those two. So the first problem is asking me to solve for the height of the cliff. So if I draw my picture again, we've got the football going up and it's coming back down. So it's wanting me to figure out this displacement right here. And one other thing, we also know the time over here in the horizontal column is also going to be 5.6, because the time vertically and the time horizontally are going to be the same. So I know here this vertical velocity is 6.36. The velocity here is 0. And this exact same point across right there, that velocity is going to be negative 6.36. And we also know that that displacement at that point is 0. It's going to go up a certain amount of distance and come back down, and it's at the exact same point. So that overall displacement is 0. So that can help me solve, because the rest of the way it falls down is just the height of the cliff. So I can just use this equation to solve for the height of the cliff. And we're going to go from start to finish, and that from start to finish, the overall displacement will just be the height of the cliff. So I have delta x is equal to 1/2 times negative 9.81 times the total time from start to finish, 5.6 squared, plus the initial velocity, 6.36 times 5.6. And if we calculate that out, we're going to get a displacement of 118.5 meters. So the next problem wants to know how high does the football go. So it's wanting me to calculate that displacement right there. So I already know that it's 118.05 meters above the ground, because that's the height of the cliff, and then I just need to figure out the displacement from how high from the top of the cliff to where the velocity is equal to 0. So I can use this equation. The final velocity is equal to the initial velocity, we'll do squared plus 2a delta x, because I don't know the time. So I do know the maximum velocity up here at the peak, that's 0. The initial velocity up is 6.36 squared plus 2 times negative 9.81 times delta x. And when I solve that out, I get delta x is equal to 2.06. So I just have to add that to the height of the cliff, and then I get my overall how high it goes from here to here, and that comes out to be 120.11 meters. So the last problem is the easiest. It wants to know how far the football is thrown, so it's asking for the range. So we're going to use what we know horizontally to solve for that. So there's only one equation you use for the horizontal portion of a projectile that's launched on an angle. So we calculated the horizontal velocity already by using our trig function, 6.36. We were given the total time, 5.6, and we get a horizontal displacement of 35.62 meters.